Today, we're going to be talking about large language models, RAG, retrieval augmented generation, and then RAG on Postgres. And I'm going to go fairly quickly over the first two things because I really want to get to playing around in with VS Code with developing this application. So first, LLMs. It's already been talked about a bit today. If you caught Alfredo's session about synthesizing data using LLMs. But basically, a LLM is a large language model. It is a model that is so large that it can now be used for general purpose tasks, such as answering questions, sentiment analysis, entity analysis, summarization. We used to have to always make custom models for each of these tasks, and now we've got these LLMs that we can use for a wide variety of tasks, and that's pretty exciting, especially for somebody like me who wasn't really ever into ML, but now I feel like I've got something I can work with and play with. Now, there are a growing number of LLMs, and so I always have to update this table here. And in fact, I saw just like 30 minutes before starting this talk that Snowflake just announced a new LLM. So it's pretty exciting that there's these more and more LLMs coming out all the time. And you probably have used an LLM. So, in the chat, mention what LLM you've used. Have you used it for GitHub Copilot? That's built on LLMs. Have you used it with ChatGPT? Have you used it in your own work? I'm really curious to see, what people are using these days. Now, some of these LLMs are hosted, meaning that we're, referencing them on another company's servers. And we usually have to do that for these large language models because they're so huge, they require so many GPUs that it's just hard for most of us to be able to set up that sort of infrastructure. I know I can't set that up. But some of these models are actually so small, like these ones at the bottom here, like Phi-3 and Mistral 7 billion. Those are so small that we can actually run them on our computers. Like I can run I'm running Phi-3 right now on my Mac. So we're going to actually try out both of these today, which is fun. And I tend to use the OpenAI SDK when I'm working with LLMs. There's lots of libraries that you can use to work with LLMs. The OpenAI SDK was the first one that came out, and it is fairly compatible with both, obviously, the OpenAI models, but also many models have OpenAI compatible API endpoints. So we can actually point it at things that aren't just OpenAI models. So I can show that here. All right, so here I have a Python file in VS Code, and I can actually switch between different OpenAI models and providers. So I can use Azure OpenAI. I can use Ollama, which is a local running OpenAI compatible endpoint that can run any of these small models. And then I can use OpenAI.com. So I have all those options, and I can just change in my environment file what I want to use. So here I'm actually using Ollama. And you can see, like I actually have Ollama running here. So I've got the Phi-3 model. I've also got the Llama 2 model. There's various models that I've downloaded. So let's try this out with Ollama. And I'm going to ask it what Python frameworks I use to see how accurate of an answer it comes up with. So it is now sending off a request to the Ollama local endpoint. And this one says, I'm not sure, and, tries to kind of guess and offers to give more information. So it's trying to be very helpful, but it's not confident because this is just based off of what's inside its weights. And in this case, we're using the Llama 2 7 billion parameter model. So there's not a whole lot in those weights. Now I could switch this over to Azure to use GPT-3.5. So let's see if we get a different response with Azure. And you also notice I'm specifying a temperature of 0.7, which is temperature can be between 0 and 1, and 0.7 is actually a fairly high number. So that means it tends to be more creative. And this one says, sorry, I don't have access to specific information about individuals. But then it still tries to make a guess. So that's interesting. So we tried to ask questions about me, and we didn't get a very satisfying answer. It didn't have a lot of confidence. And that's one of the big limitations of LLMs is that they're trained off of knowledge on the internet, but that means, at a certain point their training cuts off, so their knowledge is outdated. And also they don't have any internal knowledge. So if I wanted to ask it about something that's not on the public internet, there's just no way for it to know that, right? So, how can we get LLMs to answer questions accurately? That is what I am so interested in and what I spend all my time on, because I love LLMs. I think they're very good at synthesizing information and summarizing information, and they can make information more accessible. But I also don't want LLMs to be giving out incorrect answers. So how can we incorporate domain knowledge into LLMs? So there's three general techniques. The first is prompt engineering. This is only, this is where we like kind of rewrite our prompt, and this is only going to work if that knowledge is somewhere in its weights. So most of the time it's not going to work. It's only going to work if you're like trying to get it, you're saying, oh, give me a response about Python 2 versus Python 3. Like you're trying to steer it towards something that's already in its knowledge. That's where prompt engineering can work. But if it's just knowledge that's not in its weights at all, prompt engineering is not going to work. The next technique is fine tuning, and that's where we actually like train an existing model with maybe thousands of examples to incorporate new knowledge into it. And this can definitely be a technique we can use to incorporate domain knowledge, and it's something that lots of people are using, but it does cost money to do the fine tuning, and it costs more money to run a fine-tuned model. So we generally don't want to do that unless it's very much necessary. And the final technique, and this is the one I know and love the most, is retrieval-augmented-generation, where we temporarily give that information to the LLM so that it can answer something accurately. So let's dive into RAG. How it works is that we ask the question, let's actually just open this up. All right, so I've got the app running. All right, so this is an app that has access to data about me, because it has access to my blog. So I have ingested all of my blog posts from the last 15 years. All right. And so I'll just say, what Python frameworks does Pamela use? I'll even have an example question there. Okay. And you can see it answers, Pamela uses the following Python frameworks: Fast API, Django, and Flask. And it has citations. And these citations are actually blog posts that I've written. And there you can see this is what my blog post looks like. This is very similar code to what I was showing today. So this is how you're using RAG, is if you get an answer that has citations, that means the LLM has answered a question grounded in some actual knowledge. And so you can see this is the actual information we sent to the LLM to say, hey, you need to answer this question based off of this information. So the way that RAG works is that when we get this user query, we use that user query to search some sort of database or search engine in order to get back matching results for that search query. And then we pass both the original user question and those search results to the LLM and say, hey, LLM, here are the search results. You need to answer this question based off these search results. And if it's not in those search results, do not answer the question. So you can see here, this is our, kind of thought process, right? So we do this search, we get back these results, and then we send those to the LLM and say, hey, you got to answer based off the sources. Here's the user question, and here are the sources. So we're using the same chat completion API, that I showed in that simple demo. The difference is just that we're sending in the information just in time. So that's the idea of RAG. Now, I really want to stress that the search step is super duper important, because these LLMs, if you give them good information, they'll give you good output. If you give them garbage, they'll give you garbage output, right? So you really want that search step to find the, the matching documents, the matching rows, whatever that matches the user query. You also do not want to give an LLM too much information. They did a research on this. There's a paper called Lost in the Middle, where they, looked at how much context you could send an LLM and whether it could find the answer. And basically, at a certain point, if you send an LLM too much information, too many sources, too many matching documents, then it may miss the answer. So you really want to be able to find it, send it like a small number of matches, like, okay, here's five things that match the user's query, and answer it based off that. That's what you want to strive for, is really, really good search results. So in fact, when you're building a RAG, it's less about how you use the LLM, and it's more about how you do a great search. Now, when you're searching for things, imagine you're searching for text, right? I just searched my blogs. There's two different approaches to searching text. One is our classic doing a full text search, right? Like look at the query, Python framework, and then searching all the text for Python framework, and then giving back the matches. The other approach is vector search, and that's what lots of people are talking about these days, where you take a bunch of text, you embed it into a vector, which is an array of floating point numbers, and it represents that text in like this huge semantic space, so that things that are like that text are located close in that semantic space. And that way you can, if I search for Python framework, but my blog post, says Python library, library and framework are similar in that vector space, and so it can match it. So the best search is actually if you do both a vector search and a keyword search, and then you merge those results together. That's what we call a hybrid search. And that's what we always want to strive for in order to get the best results for a user query. Because sometimes a user is searching for exact terms, and sometimes a user is using like a synonym of something, a similar word, and we want to search those similar concepts. The other thing we need to think about is, what are we actually searching on, right? What is this search being done on? So we could do a RAG on documents, and that's in the case of my blog, that's like doing a RAG on a bunch of documents, and this is what we call like unstructured data. So if we're doing a RAG on a bunch of documents, then we actually have to go through this whole long process where we, extract all the data from the documents, we chunk it up into chunks, right? Because we don't want to send too much to an LM. The document might be really long, so we chunk it up, we turn those chunks into vectors, and we store them. And that's how lots of people have talked about RAG, and I've given many talks on that in the past. What I want to talk about today is doing RAG on database rows. So imagine you have an existing database and you want to be able to ask questions about the rows in that database. So in that case, all we need to do is have some way of searching that database, and ideally doing, hybrid search, including a vector search. So that means we want some way of storing a vector version of those rows and being able to search that vector column. So we have many vector databases that support being able to do a hybrid search. So I'm going to be showing Postgres using the PG vector extension, but there's lots of other options as well, depending on what database you're using and whether it has vector support. Okay, so let's dive into doing RAG on Postgres. And now let's just get into VS Code so we can start showing that. So here is my VS Code, which has a RAG on Postgres. So first, let me show you that I am using a dev container in order to set up a local Postgres inside this dev container. So I have this docker compose.yaml that actually brings in the PG vector image and sets it up as a local Postgres. And this is our local password only, not in production. Right, so that will set up a PG vector. So there is actually a Postgres database running inside this container. That is one of my favorite reasons for using dev containers, is when I want to work with databases and have it all set up inside this environment. And you can see the Postgres server running. You can see the port for it, 5432. And I also have the SQL Tools extension. And the SQL Tools extension lets me actually go through the tables in my database. And this is the local database here. So here you can see I have an items table. So I'm going to click on this. And this is what we have. So the table I'm using here, this is basically a product items database here. So you can see we've got, ID, our primary key. We've got the type of product like footwear or bags. We've got the brand. We've got the name. We've got descriptions. We've got the price. And then we've got this embedding column. So this is one I've pre-calculated using the ADA002 model from OpenAI, and just stored it in this column here. And you can see how I declared this in SQL Alchemy, which is a ORM for Python. So for that embedding column, I use this special vector type, which is from the PG vector Python library. Okay, so that's running. Now let's actually run this app. So I'm going to run it using the run and debug. And I'm going to use this compound launch to start up both the front end and the back end at the same time and have them both be in hot reload mode. So let me show you what my launch.json looks like, because this is super handy. Ooh, and they're starting. So in my launch.json, I have all these configurations. So I've got the front end configuration, and that is doing npm run dev, which is reloading React files. I've got the back end configuration, which is using Python to use Unicorn to run a fast API app. And then I have a compound configuration, which will actually launch both of these. So this is really cool because it's launching both of these, and both of these are in reload mode, which is just really nice development experience. And then I also have them open both the front end port and the back end port. So if I want to, this is a Fast API app, so I can directly use the API Explorer from Fast API, which is so cool. If you've never seen this before, it just auto generates this for us. Or I can use the front end. Okay, so this is my RAG on a Postgres database. So let's go ahead and see what is the best shoe for hiking. So this is going off to to the Postgres database in order to do a search for hiking shoes, and then it went off to an LLM and got back the response. So there we go. It says, I'd recommend this and recommend this one. So that looks correct. What we can do now is look at the thought process to get a better idea for what happened. So it searched the database using the user query, but also doing a vector search. So it did both a full text search and a vector search. So that way it could find, things that match the vector. And that's really helpful because, I think otherwise we can actually try turning off doing just a text search. And let me try this out and see what we get. We probably won't get much of anything. And let me show you the code. What does the code look like for doing that search in Postgres, right? So here's our vector, doing a vector query. So we do a select, and this is the order by, and this is the cosine distance operator. So when we're searching on vector fields, we need to use some sort of distance operator. And when we're doing eta 002, we want to use the cosine distance operator here. So that's what this is. Then we have the full text query, and this is how you do that in Postgres using this TS vector functionality here. And so that'll try to do some, good full text searching. And then we combine them together, we merge them and try to rank the results together in order to get back all the results. So what you can see here is what happened is that it found no results because I only did the text search, and best show for hiking just didn't match anything because there's too much stuff happening in that query. So we got no results. So the LLM actually made up answers. So that brings me to the next thing is that I am currently using Phi3 locally in order to answer this. Now, what I could do is change this over to using an Azure model. So I'll change it to Azure, and then I want to get it to auto reload. So what I do is if I'm changing .env, it actually doesn't auto reload, but I just enter a new line and save, and then boom, it's auto reloading, right? So I just need to change something in the Python and it'll reload. All right, so now let's try this with, now it should be using GPT-3.5, and we've changed it back to hybrid again, and we'll click best shoe for hiking now. And so now it's going off to OpenAI in order to answer the question. And here we see, oh, it still says vector search false. Okay, so let me go back into hybrid. And now this is interesting though. Now what you see is that GPT-3.5 refused to answer the question. So that is definitely a difference you see in the LLMs when you go from, the small number of parameters, the local models, to the hosted large models, is that generally the large models are better at, they're better actually at being humble. They're better at saying they don't know, and admitting that. GPT-4 is the best at saying it doesn't know, which is a really good attribute for RAG. Okay, let me make sure. Come on, this should be hybrid now. Let's try that again. And we can also look at the code here. So for the for this RAG, right? We get back whether we're doing hybrid or not. And if we're doing a vector search, right, then we do need to compute an embedding for the user's query. So we compute an embedding using the same model, the ADA002 model that we use to make that column. And then we send in both the query, the query text and the vector version of that into our Postgres search function that does those SQL queries I showed you before. And then, we combine all the results together. We send that to the LLM with our system prompt and use a fairly low temperature and then get back the results. All right, so here you can see this is a good answer. This time we're using GPT-3.5 Turbo and we're doing a hybrid search. So we got back good results here. And this is actually a great answer. This is an accurate answer and this is working well. So this is cool. This is working. I wanted to take it further. So let me go back to the slides here. Okay, so we did a RAG on database rows. And we did a hybrid search there. So right, with a hybrid search, we get that user question, we embed it, we use both the vector and the text in order to do that hybrid search, and then we send the original user question and the results to the LLM. Now, what about a question? Let's look at these example questions here. What about this question here? Climbing gear cheaper than $30. So this is an interesting question because it has, you can imagine that as a SQL filter, cheaper than $30. So if I do like a vector search for cheaper than $30, that's not going to really get good results. Like that's not something that's really encoded in the vector space very well. What I really want to be able to do is to filter and say, hey, find me the climbing gear where the price column is less than 30, right? Like I want to actually be able to do that SQL, that additional SQL where clause, right? So that is something we should be able to do with a database and when we're doing RAG over a database. So that's what we're going to do is we're going to figure out how can we turn this query here into an additional SQL filter clause. And the way we're going to do it is to add a query rewriting phase. And this is a very common part of most RAG applications is to have some sort of query rewriting or routing or intent phase where you take the original user's query and you kind of structure it more and say like, okay, like this is actually what we should be searching with. So the way I'm going to do that is to use a LLM that supports function calling. So right now that's mostly the OpenAI GPT models, but there are a couple other ones that also support function calling. And they call it function calling. You can also just think of it as structured output. So I need to be able to tell the LLM like, hey, I need you to actually respond in a very structured way, and this is what that structured look like. So I'm asking it to actually respond and say, hey, imagine I had this search database function. What query would I send to it to, and what filters would I send into it? So that's in this query rewriter file here. So this is what it actually looks like when we're defining functions to send to the LLM. So we say, okay, you're going to tell me what search query I should use. You're going to tell me what price filter I should use. And yeah, so ideally it's going to look at the user's question and then respond back and tell us what search query and what price filter to use. So what I'm going to do is just switch over my simple RAG to my advanced. I want to do advanced RAG. Okay. All right. And save, and it'll auto reload because it's awesome. Here we go. And now let's try this question. Dun, dun, dun. Moment of truth. So this should be a little bit slower because it's now got an additional step in it, right? It's got an additional call to an LLM. So it could be significantly slower because we've got to do that first call and say, hey, here's the user's query. How would you turn that into a search query and a filter? We'll see if it's going to do a good job this time. Now, something to point out while it's doing this, oh, and it's back. I cannot do this with the local Phi3 model. It doesn't, Ollama doesn't support function calling yet, and Phi3 doesn't support function calling on its own, although I read actually that it looks like it should be able to be easily tweaked for that. So for this advanced RAG, I have to use the GPT models that are on OpenAI or Azure OpenAI. Okay, so look, it answered. It says we have 2 climbing gear options under 30. And then if we look at the thought process here, we can see it did actually get back that it should do a price filter less than 30. And then it got back only things that were less than 30. And if we look back at that Postgres searcher file, you can see that I had this little thing here, filter clause where. So I've, got this code here that will build the where clause based off of what comes in. So we could actually just add another filter. So let's try this because I have a couple minutes left. So let's say I wanted a brand filter, right? That's another column. And, maybe people really like their brands. And these are all made up brands. So no Nikes, but we can just make it up. So where I'm going to say, okay, I'm telling the LLM like, all right, we want a brand filter. So, operator should be either equal or not equal. For some reason, they really didn't want a brand, I guess. And the value should be a string value to compare against, e.g. Airstrider. That's one of our brands. Okay, so that looks good. So that's telling the LLM that's a potential argument it could pass in. And then here, this is just the code where I extract the answer from the LLM. So I'm going to go ahead and just extract it here. And yeah, this is a little redundant. So, we can definitely clean this up in the future. But column is going to be brand. Okay. Okay. Looks good. Let's give it a go. Any shoes from Airstrider? So the hope is that it's going to realize that this is a brand and that it's going to suggest doing that filtered column search. And some of this stuff, like you don't necessarily need, because the LLM is eventually going to see the brand as well. But the nice thing about doing this filtering is that we can significantly like reduce the possible things that we're going to have the vector search for. Okay, there we go. Let's see. And look at that. It did the brand thing. So that's good. That works. And we could use that for any of our columns. And you could even imagine just asking it to just generically, tell it the columns and have it generically decide which filters come up with. I'm being really specific here because I am, I don't want to like let users just inject random where clauses. So I'm being really specific and saying, which things I'm okay with the filtering on. But I think there's a lot of flexibility here, and I'm pretty excited about it. And I love seeing it work the way it does here. So there you go. And if you're interested in that, I just made the repo public. Let me reload. It should show as public. There you go. Now it's public. So you can go ahead and, check it out yourself. And I'll keep working on it, making it more usable and also making it deployable on Azure in the future as well. So if you are excited to get started with RAG, in this case, I showed using the OpenAI SDK. There's many orchestration libraries that will do a lot of this for you. Like LangChain even has the filter building itself. It's called, and built in, it's called self-query retrieval. Llama Index probably also has that option too. I have to figure out what it's called. But these are 2 really popular ones in Python. Semantic kernel is very popular for .NET. PromPtFlow is something from Microsoft that's also Python. We also have many RAG chat app starter repositories. So there's the one I just showed. There's quite a few that use Azure AI Search that are for RAG on documents. So if that's what you're interested in, check these out. And that is what I wanted to show today. So thank you everyone for watching, and I am happy to answer any questions.